So now we set our boundary conditions. So like the front boundary condition was, oh, I don't know, what was it? We got a velocity inlet here at 30 meters a second. On the back side, we'll use a pressure outlet condition. Pressure outlet. Let's see. On the top face of the box, like the one that doesn't touch the cars, and the other side face that's not the road. So these are really kind of fictitious boundaries that are like ideally would go to infinity. We just can't do that. What we want to do there is just let the fluid slip past the wall, so it's like an impermeable wall, but one that allows the fluid to slide past it. So that's called a slip wall. We'll set it up that way. There's a mirror symmetry plane where the cars have been cut in half. So we'll select a symmetry boundary condition for this plane. Let's see, what else? What are we missing here? Oh yeah, the ground. So the ground is moving at 30 meters a second as well. So that's a special wall condition. It's a wall where the entire wall is being modeled as moving at a fixed velocity. So in this case, like ux would be 30 meters a second, just like the oncoming flow is 30 meters a second. And then, let's see, I think we got all of the ones that don't have anything to do with the car so far. So let's reset our view here. Okay, so now we need to set all the ones that have to do with the car. So first let's make all of these other walls disappear. They're kind of obnoxious for setting up things. We'll just right click and then hide faces. Okay, so these are all our vehicles. For the easiest boundary condition to set first is the no slip condition on the outside of our cars, which we're imagining are stationary. So like we'll select the bodies and then set a wall condition, which the default is a no slip condition. We'll just accept that. Boom. So that's good. And then we need to do something about all these wheels. So we don't necessarily have to hide the cars for this. In fact, I like to have them there just to remind me what I'm doing. Sort of blow this up a little bit. Okay, so now what we need to do is go through each one of these wheels one by one and make them rotate about their correct axis of rotation. So I'll do this pretty slowly for the first wheel so you can see what happens here. So first I'll click on boundary conditions. Actually, yeah, okay, fine. I'll click on boundary conditions, wall, and then one of the drop-down choices here is a rotating wall. So let me select that. Now, it needs to know, like, so which faces are rotating. So it needs a couple of things here, right? It needs to know what is the axis of rotation. So that requires both a point on the, like a point, a direction for the vector that defines the axis of rotation, and then how fast things are rotating about that axis. And for all of that, it needs to know what faces in your simulation are doing that. So first things first, let's select our wheel. So like this is meant to be the front wheel. So I'll click over on my save selection of the front wheel. First I'll set my rotational axis to be -1 in the y direction and then 0 everywhere else. Okay, first let me talk about the -1 here. Why -1? It's because if we're using the right-hand rule, what I'd like is that when I perform the right-hand rule about the axis of rotation, the moment arm times the velocity points in the direction that I want it to. So, like defining the rotational velocity as a positive number. So, in order for me to get the wheel to actually rotate forward, I need to choose the axis of rotation to be -1. Go ahead and check it out with the right-hand rule. Now, that's just the direction of it, but it has to pass through the center of rotation, which I haven't selected yet. So in the sim scale tutorial, it says for you to type these in. I think that's like the sucker's way to do it. There's this little thing up here that says pick the center of the current selection. So my current selection is the faces of a wheel. So the centroid, or the center of it, is going to be the centroid of the wheel, which is the axis of rotation. Or is the point that is like the center of rotation goes through. So if I click this button, boop, it's going to move that that arrow over to the center of the circle that defines the wheel. So then I don't actually have to type any of these crazy numbers in there. Okay, got it? And then the last thing you got to figure out is the rotational velocity here. This actually requires a little bit of paperwork on your end. Basically, what you have to know here is that we've got a 15-inch wheel, or a different way of figuring this out is like, for example, if I look at, the ground is at y equals 0, and this is, what do you call it? This is the radius, right? The radius from the ground to the center of rotation is like 0.927. But I want the thing to rotate at 30 meters a second. Let's just do a little side work in, sorry, this is a separate thing. Let's just do a quick bit of side work in Python. So, let's see, I don't know if I can make this font any bigger, can I? Yeah, I can. Okay, so what I want is for the velocity, so that's like omega times r should be equal to the velocity of the wheel. I want this number to be 30 meters a second, and I know the value of the radius. It was whatever was shown on that screen. What was that? It was 9. Here, I'll just copy and paste it over. It's like 0.9271. So that means that omega is actually 30 divided by 9271 in radians per second, which is 32.5. Did I do that math right? Does sound right. Must be right. I need to go back and check that number. But anyway, the point is that there's a way to calculate the the angular velocity in radians per second. So what did I say that number was? 32.35. Boop. Cool. Now I've got to do that for every one of these other wheels. So a couple ways to do that quickly. Let's see if I can remember how to pan. Pan. Where's the pan? I could actually just repeat that process for all of these wheels, and I pretty much will. But one slightly faster way to do it is, well, first let me save this one. So this was our front wheel 1 condition. Now what I can do is just duplicate this 6 times and then just go through and change the center of rotation for each one, since each of these wheels otherwise has identical specs. So like this is, let's call this like rear wheel 1. And then for rear wheel 1, the main thing is that the assigned face is different. It'll be the rear wheel, and then we'll have to recalculate the centroid and slide it over. Save it. That's our rear wheel, and then we just got to go through and do that, I guess, like 6 more times. So duplicate. So go front wheel 2, and then we'll grab front wheel 2. Where's front wheel 2? Recalculate the centroid and accept. And just keep doing it. So this was supposed to be rear wheel 2. Recalculate. This is front wheel 3. Okay, let me select it. This is rear wheel 3. It's supposed to be. Let me change the name here. I don't want it to be too confusing. It's supposed to be. Ooh, I'm actually already confused. It's supposed to be rear wheel 2. And what was this? Okay, fine. Looks like it's front wheel 3. So we can always add it. Let's see what we got. Front wheel 4. When we're done, I'm going to go back through and check and make sure that I did all these correctly. It's pretty easy to mess this up. Rear wheel 4, should. be associated with rear wheel 4. And we need to recalculate the centroid, and then do the same thing for the last car. You can see like how having a good workflow here can really reduce the amount of time it takes to do this. It takes a while even if you know what you're doing, but if you don't know what you're doing, you can spend a lot of time doing this. Alright, last one, rear wheel 5. Calculate its location and set it up. I'm going to go back and check that radians per second, but before I do that, I'm just going to walk through each one of these and just check to make sure I got the location right. So just when I do this, I'm just looking at where the arrow is on the screen. Like, just make sure that the arrow is actually associated with the wheel that you think it is and at the location you think it is. So this was supposed to be front wheel 1, rear wheel 1, front wheel 2, rear wheel 2, rear wheel 3, front wheel 3, front wheel 4, rear wheel 4, front wheel 5, and rear wheel 5. Alright, looking good. Alright, I went back and I checked on the rotational velocity, which I thought there might be an issue with, and indeed there was. So, like, it turns out that I had used the wrong dimension here, so the calculation involves knowing the radius of the tire, which is the distance from the ground to the center of rotation. Turns out that's actually the z-axis here. So if I take the point like on the tire that's at the centroid, that'd be this like 0.377 meters number, and I use that for the radius and then go back to that Python calculation. If we had used the correct number, we would actually get 79.5 radians per second. So this is the number that I should have been using in those calculations. So all that needs to, we don't need to like redo a lot here, and I'm not going to go through it on the video, but just for all of these wheel calculations, I need to go back and change all of these rotational velocity numbers to 79.5 radians per second. So I'll do that offline. We don't have to do that in this video. So that's basically all of the boundary conditions, and then there's other things to do like set up the mesh and stuff, but that doesn't need to be part of this video. Alright, I went back and I checked on the rotational velocity, which I thought there might be an issue with, and indeed there was. So like, it turns out that I had used the wrong dimension here, so the calculation involves knowing the radius of the tire, which is the distance from the ground to the center of rotation. Turns out that's actually the z-axis here. So if I take the point like on the tire that's at the centroid, that'd be this like 0.377 meters number, and I use that for the radius and then go back to that Python calculation. If we had used the correct number, we would actually get 79.5 radians per second. So this is the number that I should have been using in those calculations. So all that needs to, we don't need to like redo a lot here, and I'm not going to go through it on the video, but just for all of these wheel calculations, I need to go back and change all of these rotational velocity numbers to 79.5 radians per second. So I'll do that offline. We don't have to do that in this video. So that's basically all of the boundary conditions, and then there's other things to do like set up the mesh and stuff, but that doesn't need to be part of this video.